Hi, good morning. I'm Nikhil Mittal, and you're in the session Red Team Revenge Attacking Microsoft ATA. So let's get started. Thanks for coming to the talk. And I cannot move. I usually move around a lot while speaking, but yeah. So I'm a hacker. I do a lot of red teaming. I train at conferences, do private trainings, speak at conferences. I'm associated with Pentester Academy. Uh, you can find me on Twitter as Nikhil_MITT, so please go follow me. I'd really like to see my Twitter follow count increase after every talk. I blog regularly on labofpenetrationtester.com. That's my home on the internet. I maintain two open source toolkits for red teamers, Kautilya and Nishang. Kautilya is a toolkit which you can use to create ready-to-use human interface device sketches. So it generates either a PD or a INO file, which you can burn to your Arduino device, connect it to an unlocked box, and it types interesting stuff out for you, whatever you programmed it to do. Nishang is a tool which is a collection of, it's sort of a framework, which is a collection of PowerShell scripts. You can generate scripts that are ready-to-use scripts as well for different phases of a red team engagement or a penetration test. I'm generally interested in, of course, where I have the permission to do so. I would like to try new methods of breaking into boxes, bypass defenses if there are any, which of course helps both the red teamers and blue teamers. I've previously spoken at DEF CON, Black Hat, trained at CanSecWest, BrewCon. This is my first 44Con, and I'm really liking it. So what is Microsoft ATA? What is the theory behind it? Those of you who regularly pen test or attack Active Directory networks, you will see that logs are not something which provide you, especially if you're on the defense side or on the purple team side, logs are not something which provide you an insight on all the attacks. There are some attacks which cannot be detected as easily in logs, maybe as easily by looking at the traffic. Or logging could be something which is much more, there are so many logs. If there is another way of not looking at the logs, but looking at the traffic somehow, which allows you to get a better insight into attacks in your Active Directory environment, then how would it look like? It would look like Microsoft's ATA. ATA, the textbook definition from Microsoft Docs is, it is an on-premises platform that helps protect your enterprise from multiple types of advanced targeted cyber attacks and inside threats. I mean, so many marketing keywords in here. But the point is, ATA, as I have encountered it in my real world assessments, ATA to much extent actually provides you insight into what an attacker may be up to. It reads all the traffic on your domain controller or domain controllers. You need to mirror all the traffic going on there to the ATA sensors, and it reads some interesting protocols like Kerberos, LDAP, and others to see if there is any anomaly in the traffic from our regular traffic. That is, it builds up a profile of all the users and machines over time. There is an initial learning period. In fact, it can detect behavioral-based attacks. That is, a user accesses a resource which he or she does not access regularly, and anomaly-based attacks. That is, those are the ones which we are going to have a look at today. For anomaly-based attacks, there is a learning period of 1 week. For behavior-based attacks, there is a learning period of 3 weeks. In fact, there are some anomaly attacks for which there is no learning period required, but we are not going to jump into the learning period right now. So this is ATA's basic architecture, which a diagram has been created from the one which you can find in the docs directory, which is a bit better than this. So this is the ATA gateway. This is the component which you can either, in case of small installations, install on your own domain controller, or it is a separate box which looks at the traffic and all. And then everything is sent to ATA center. It is at this place where user or machine profiles are stored. And the console, ATA console, which provides you access to the alerts, is on this box. So you can have log forwards, traffics, event forwarding, etc., as traffic source to the ATA gateway. In the lab where I have tested, so when I do trainings, I have multiple labs. All of them have ATA configured and installed. So over the past 1 year, almost 1 year, when I've been using ATA, more than 450 of my students or attendees have tried attacks against ATA. So if we find any bypasses for any anomaly-based detection, that is quite sure that that is a solid bypass. If you can see so many of us trying things, so many professionals and hackers trying things across an installation, and still there is no detection, that means that the bypass is a solid one. We are going to use ATA 1.8, which is the latest version as of right now in the lab or in the demonstrations. Threats of interest which ATA detects in Recon phase, account enumeration, session enumeration, Active Directory enumeration, that is, if you are trying to have a look at groups, sessions on boxes, user hunting, looking for local admin access. If you're running attacks like this, it tries to detect them. Then compromised credentials, that will attacks like brute force or unusual protocol implementation. We'll see what's there. Abnormal behavior. We are not going to have a look at the behavior-based detection. Then the most interesting part, lateral movement. That is something which ATA specifically has been designed for. It focuses really a lot on lateral movement attacks like pass the ticket, pass the hash, overpass the hash, abnormal behavior. Once again, we are not going to have a look at abnormal behavior. Then comes domain dominance. So if I do not want to use that word right now, but that cyber kill chain which Lockheed Martin made popular, the last thing comes from there, the domain dominance part, that is the domain persistence, which us mortals call persistence or maintaining access. Marketing buzzwords call them domain dominance. That is, once you have privileges enough in a domain, let's say a domain admin or an enterprise admin or something interesting which you think is interesting, you may like to maintain your access, persist in that domain. That's what domain dominance is, which contains golden ticket attacks, malicious replication requests, that's DC sync attacks. These are the attacks which ATA detects. Now, how would you avoid that? So we are going to have a look at two things in the presentation, or two phases. One would be how we can avoid detection, which I talked about a bit previously as well. And then how would we identify ATA installation in a domain and directly attack it? So if you are pissed off at ATA for some reason, you can directly attack it and make it do interesting things for you. So in case of detection, ATA detects attacks like this. So if we have, let's open up this ATA here, and this is how it looks at the enumeration. So is it visible till back? Those sitting at the very back, can you see the text? Okay, good. So this is SMB session enumeration. This is Recon using directory service queries. So when you see things like this, SAMR is a protocol which, so let's first address this. SAMR is a protocol which is used by, let's say when you run net group / domain, it is that thing which is visible here. Avoiding this is as easy as using tools like PowerView, which use LDAP for enumeration. ATA is interested only in authentication traffic when it comes to LDAP. So in this case, just to avoid things like if you'd like to see all the users in a domain or all the boxes in a domain, group memberships, just do not use things like NAT. Use maybe tools like PowerView. Then when it comes to some interesting enumeration, that is, let's say there's a very popular way of looking for domain admin privileges, which is also called user hunting, looking for a particular box where a domain admin token may be available and you have, let's say, local admin access. For that, if you closely look at the message which ATA provides us, SMB session enumeration attempts was successfully performed by some user from some box against ops DC, which in my lab is the domain controller. What does this message mean? This means ATA does not has no problem providing you asking information from the domain controller like the boxes, the member boxes, or the users or the group membership, but it has a problem if you would like to list sessions on the domain controller, or if you would like to list logged on users on the domain controller. That is, as long as you are asking very innocent information, that's fine, but as soon as you move on to a bit intrusive enumeration, it complains. But because ATA has a sensor only in front of the DC traffic, that means you can extract information from DC, but while doing the intrusive enumeration, just remove the DC from the list of boxes you are going to enumerate. That is, not poking the DC, not talking to the DC is the key. Not only in this case, in all the cases, if you're avoiding talking to the DC, if you can, then ATA would not be very useful. So for example, let's say we have a list here. If I get a list of boxes, so these are the users in the member computers in this domain, which we can simply get using something like PowerView. We simply run getnet computer, and we get a list of all the member computers in the domain. Please note that in the list which we have here, we have just made one change. There is no domain controller in this list. So we've just removed this part. Right, and now if we run as intrusive enumeration as this, ATA will not complain at all. Why? Because we are not running the intrusive enumeration against the DC. It is fine as long as you just extract the information, but as long as you are not listing the session, it is quite clear that it complains about session enumeration. That's what it has problems with. So as long as you avoid running, or let's say invoke user hunter blindly without removing the domain controller, ATA would be fine with that, and there is no detection for that. So you can use it for, let's say, looking for local admins or any interesting thing which would like to. Just keep in mind that only extract information from the DC and do not run intrusive enumeration against the DC itself, and you will be fine with that. Okay, then SPN scanning, a popular way of looking to for those services whose SPN is registered with the DC, is not detected at all by ATA. And as far as I know, there are no plans of doing it. So that's another very interesting enumeration which doesn't get detected. Of course, that's not on the slides right now because I'm more interested in going through the attacking ATA part. But for example, if you use brute forcing, the horizontal one, the well-known one, where you try a single password against multiple domain users, and because it's a single attempt, there will be no lockout, that also doesn't get detected. Once again, because it depends totally on the tool. So if you're using a PowerShell script like one from Nishang invoke brute force, it doesn't get detected because that uses LDAP queries. Of course, if you're going to use well-known tools like Hydra, etc., there is a detection. Now, once we have identified, let's say in this case, let's make a quick assumption that we identified some boxes where we have a domain admin token available. There are many. There are domain admin tokens available. We just, let's dump the credentials, that is hashes, NTLM hashes of the domain admin. That's what credentials are. You cannot extract them in clear text anymore. So if you have access, let's say, to the NTLM hash of a domain admin, our next step is lateral movement. We would like to use attacks like Overpass-the-Hash to use those credentials to access other resources, right? So if you may like to read about Overpass-the-Hash more on Benjamin's blog, the guy who wrote Mimikatz. So how ATA detects it? So this is the normal traffic, the AS request packet. When you have a look at this packet, there is a specific field called E-type, which tells you the encryption type being used. You can see here it is AES-256. In case of Overpass-the-Hash attack, if we are using NTLM hashes, this field is downgraded to ARC4 HMAC MD5. And that is what AT tells you. If we can, maybe no longer in 1.8, but that's what ATA tells you if you'd like to see in 1.7 at least. The encryption method of the encrypted timestamp field of AS required message has been downgraded. That's what exactly it is complaining about, that you have downgraded this field. There is another detection of it. It says unusual protocol implementation. I'm not sure what it looks for. Maybe these E-types, if you see here, these may be the supported E-types. Okay, you can't see the pointer, sorry. Maybe these E-types. That's maybe the second. So one is encryption downgrade, another one is unusual protocol implementation. So probably this is the second part which it looks for. So how do you avoid detection in this case? You simply use AES keys. So from Server 2008 onwards, you can use AES keys, or that is actually the default. If you go through your logs, you'll see the encryption type for Kerberos packets to be 0x12. That means AES. So what we can do is, in place of using simply invoke Mimikatz, let's say we are using the PowerShell port of Mimikatz, invoke Mimikatz - command. In place of just using /NTLM, we also use /AES256, /AES128, or just the 256 keys. If you use these keys, your traffic looks really normal and there would be no detection. Just keep in mind that AES keys, according to Benjamin, and I've tested it, that's right, can be replaced only on either 8.1 2012 R2 boxes or on 7 2008 R2, 8 2012 boxes with this KB applied. Of course, in case of an enterprise environment, you will find this patch installed almost all the time. Right, so let's say we have this 2012 R2 box, and you can see that because we already have access to the credentials, that is keys and hash of domain administrators, which we found out in the domain enumeration phase. What we are doing here, everything else is as usual, but in place of /NTLM, we are using /AES256 and the 256 bit key for the administrator. If I run this, so great. So this should ideally open up a new PowerShell prompt. So let's try to do that once again from a new session. So, Okay, so let's just copy this and try it from a new session, and hopefully it works this time. So let's load up Mimikatz. Let's try it once again. Okay, so this new PowerShell process which starts up has the privileges of domain admin. A very easy way to identify that should be something like this, trying to access the file system of the domain controller or run PowerShell remoting or WMI queries or DCOM or whatever, and there would be no detection. Right, and how does that happen? Because you are using AES keys, the traffic looks really normal here. So that's Overpass-the-Hash attack. Once you can move laterally without getting detected. Okay, another interesting thing is you can actually generate false events if you would like to. If you use a wrong username in the command which we just saw, in ATA you can use things like this, like this. Failed Overpass-the-Hash attacks from multiple users, just in case you would like to distract blue team or anything interesting you would like to just play with it. Now, once we have Overpass-the-Hash capabilities, next comes the domain domination part. Now, for golden ticket, because we are going to create a TGT, the field of interest in the Kerberos packet for ATA now is the TGS request packet. So, of course, you can read about golden ticket more about it here. So, a normal TGS request packet looks like this, AES 256, etc. In case we are using NTLM hash to create a golden ticket, once again there is a downgrade here. So as we have learned from Overpass-the-Hash attack, the natural thing to do is to use AES keys. You can see here, and in fact I think in the case this is not readable, but it says the encryption method of the TGT field of the TGS request message from two computers has been downgraded based on previously learned behavior. So we simply do this once again. In place of using just the NTLM hash for creating a golden ticket, we simply use AES keys, right? So in place of using /NTLM or I think it accepts /RC4 in case of golden ticket, you can simply use /AES256 of the Kirby TGT account, and you will not be detected. Now, another very interesting bypass, thing which I always get asked, that how do we extract the AES keys? So, of course, we will see ways of doing that as well. For example, running DC sync attack. But if you run a DC sync attack, it actually gets detected like this. A malicious replication of directory services. So how do we avoid or how do we escape having to extract AES keys? You can simply use something like this. Use the NTLM hash, but in the user name field, use any non-existent user. And ATA, supposedly because it maintains profiles of users, it cannot actually detect it. And this is actually surprising. When I found this out before my Black Hat talk a couple of months ago, I couldn't believe. I checked it across with some of my friends that is it actually something which is present, or is it a misconfiguration in my lab, or I'm doing something silly. But no, this works up to now. So this means, let's see if I have a demo for this. I should have. So we'll stick to just looking at access to the file system. We cannot access it right now. And if I use this, that is using the golden ticket, but with, okay, need to, but with a non-existent user, that is a user which is not there, just use any random name. So the ticket has been injected, and hopefully we can access any service onto the domain controller. That is, we are back to domain admins. Now this doesn't get detected as well. Once again, I work quite closely with the ATA team. They are fantastic guys. I mean, they were very receptive with all these bugs or bypasses in the tool, but never got any clear answer about that. I mean, they are working on it. That's what they told me. But why it is not detected? Hopefully because ATA maintains a profile of all the users and it cannot find a profile. It cannot attribute it to a particular user. That could be the reason. But nonetheless, a very useful bypass. Now, up to 1.7, there was no check on ticket lifetime. 1.8 introduced checking for ticket lifetime. That is, if you create a golden ticket, and that's what most of us do, here we, in place of /ptt, we'll use something like /ticket and save the ticket to a file, keep that file with us, and maybe 6 months back, when need 6 months in ahead, if we need the persistence, we'll just reuse that ticket, right? That's how many of us do. So how many of you actually use the /ticket option if you use Mimikatz for creating a golden ticket? No one creates the ticket to the disk, really? Okay, so some of you, and I think more of you. But avoid saving ticket to disk. There are a couple of reasons for that. One, you can see here, whenever you create a golden ticket, there is, or any ticket for that matter, there is a lifetime which is associated with that ticket. Here you can see the lifetime. That means if you create a ticket and save it to the disk, exfiltrate the ticket so that you can come in later on and inject it, in those cases, ATA 1.8 onwards checks for the lifetime of the ticket. What does that mean? That means you will get some detection that a ticket was used beyond the stipulated time. That means it's an anomaly, so here's an alert. That's how it works. So this, of course, makes things difficult sometimes. So this is how that alert looks like. Here ATA can tell you the hours you have been using the same ticket, whereas the default ticket lifetime is 10 hours in a domain, and it depends on your target configuration. That is generally not changed. So if you're creating a ticket and using it again after 10 hours, then you can get detected. So to avoid such scenarios, the best way is to not create a ticket onto the file, because it's not the ticket which provides you persistence, but it's the static or not frequently changed Kerberos hash. No one really changes it. Maybe some of you, but not all, in all the times. So it's the Kerberos hash which provides you persistence. So just exfiltrate or keep the hash with you, and do not write the ticket to the disk. How does that help? In that case, you can use options like this. That is, you create the ticket and inject it right away when you need to use it. Maybe 6 months later, a year later or so. Also, if you for some reason cannot just save yourself from saving tickets to a disk, Mimikatz provides, and other tools, some private tools which also provide the same functionality. You can actually make a ticket with having a lifetime in the future. For example, here we have a ticket which has a ticket creation time set to 2 hours, and it would 2 hours from now, that is 2 hours in future, and would have a valid time of 1 hour. So if you use this within the stipulated time, there would be no detection. Right? Now let's see how we can attack ATA deployment. Now there are multiple deployment scenarios of ATA. It could be part of your current domain. It could be a workgroup box that is a separate box, which is not part of a domain. I don't think I've linked that Google doc, that doc, but the 88 docs actually discuss briefly the deployment scenario you should go for. So according to them, and which I totally agree to, if you make ATA console part of the domain, managing it would be really easy. Patch cycles or basic sanitation checking, whatever, you can manage it using your normal domain. But if the box is not part of the domain, patches or other maintenance may take a bit more effort. But here's the catch. If your ATA deployment is part of the domain and your domain gets compromised, for example, in our case, we already have the domain admin access and persistence and dominance, etc. In such cases, it is possible to attack ATA console itself for interesting things. And that doesn't mean that you always need to have domain admin privileges to attack ATA console. You must be, of course, local admin on that box. That's the basic thing you need. And please do not think that if it's admin, it's game over. That's what the theory which ATA subscribes to. And as we'll see, that makes things really disastrous. So before attacking the deployment, of course, we need to identify if there is an ATA deployment in the environment. There are some very easy ways of doing that. Up to 1.7, you could simply point any, let's say point nmap to all the IP addresses which listen on port 443. That's the default port where ATA console, this web console listens on port 443 by default. You just point it to 443, do the basic banner grabbing, and you can find out that if there is an ATA or not. But from 1.8 onwards, and ours is ours is a 1.8 version. In 1.8, there is a single sign-on. That is, if you try to access this without providing any credentials, you cannot even do basic banner grabbing. So in such cases, we can use a simple PowerShell code like this. If you run this from a domain joined box without any privileges, you do not need any special privileges. If we run this from a domain joined box, so it returned true. And what we were checking for, so for the quick demonstration, we already knew the IP address. Otherwise, you may need to run it on multiple IP addresses. So what we were looking for, if this web server, HTTPS on this particular IP, if its banner contains Microsoft Advanced Threat Analytics, that's what we did. And that's the IP 1.3 where we are running it on. So a very simple method to do it from PowerShell, because I do a lot of work on PowerShell, that's why I choose this. Otherwise, this can be done from pretty much any scripting language or programming language of your choice. All right. Now, so once we have identified it, so that's one of the ways. Now, if we do not have any domain joined machine, a very simple, well-known method could be this. Simply point SSL scan to it. That is, if you have a look at the certificate of, in fact, even in those cases where you do not have, so I am not in a mood to go through the certificate in Chrome. So if you have a look at the certificate here, you can simply see that it has been issued to and issued by ATA Center. I have not seen many, not a single installment in an enterprise which changes this. Internal certificate, self-signed or certificates are used all the time in enterprises. So this simply allows us to enumerate if there is any ATA deployment in the target environment. Now, there are some more interesting things about the ATA deployment. All the local administrators on the ATA center have administrative access to the console. That means you can simply, if you have local administrator access, who by default would have local administrator access, all the members of the local administrators group, the local users, the domain privileged users. That means that in our scenario, when we already have high privileges, or if we somehow have local admin privileges on this box, we can do some interesting stuff by going to this part, we can add exclusions, for example, for IP addresses, for users, for specific attacks. We can see the domain controllers where this is configured and other things, which makes sense, right, if you have access to the web console. But the problem with this, a bit of problem with this thing is, if an ATA administrator comes here and looks at this would be really visible, right, that there are some exclusions for a specific IP address or user that may actually give you away. So for such cases, we may like to interact with the backend directly. Now the backend used by ATA is a MongoDB server which listens just on the local host but does not need any password to interact with. So I'm still have to come to terms with this idea of not having a local authentication, any sort of authentication on the backend, but that's how it is right now. That means you can actually interact with different interesting collections over there, which looks like this. So this is the ATA backend. You can see there are some interesting collections: suspicious activity, system profile, unique entity. So unique entity is the collection which has profiles of all the users and machines and entities in the with the ATA. And then suspicious activity, as the name suggests, is the collection which lists all the suspicious activities. Now, what can we do with this? So many things. First is, let's say we have, we would like to change attribution in case of an attack. So I think I have one here. So here we can see Recon using SMB session enumeration using this user called build admin. So this is the unique ID. If you go there and change the, okay, so that's the one which is open. We can confirm this with this. It's enumerated session suspicious activity. And the field responsible for the identification of user is, it's this, source account ID. So this is something which identifies that user in ATA. This is the build admin user. So how we can do this? We go to the unique identity, look for, let's say, a particular user, let's say lab user or whatever user you want to. So we can safely assume that because you are here, you know at least this basic information about the environment. So we go here, copy this ID, that's the unique ID for this user. Go back here, edit the document, and change the source account ID. You need to change it at all the places actually, so change it here. So I'm actually working on a tool. I wanted to complete it to present at 44Con. I'm working on a tool which automates this, so you need not do it for each and every one of the activity here. So let's replace all of these. Do we have more? Yeah, a couple more. So replace. So we are replacing the ID of the build admin here with another user called lab user, or whatever user of your choice. You can simply use ID of a let's say a DA or any other user. So okay, let's do this. So many of them. Let's try to do it without changing it for all of them. Save it. And if we reload this right now, so it has changed for some of the activities. You can see that from build admin, it now says lab user as well. And if we quickly change it for all, so let's do that so that it looks much more better. If we quickly do it for all the detections here, okay. replace this. I mean, that's not very looks good to do, to manually do this, but okay, let's replace this. Okay, this. Do you have more? My God. Okay, so I'm not going to spend so much time on this. Let's see if we can see changes over here still. So not in this list. Let's quickly try it for another one. So here you can see that if we, okay, one thing which I forgot to mention here is if you are not going to purge the ticket from this session when we use we created the golden ticket, if you are not going to purge the tickets from here, there would be detection like this. So use it and straight away purge it. Okay. So let's try it for this activity. And let's see if we have the source account ID here. There is a source account ID, so we just need one for another user. And change the source account ID, right? Save, and if you refresh it now, it says it is from lab user. So of course, I mean, this makes sense. If you are going to make changes in the back end, the front end will show the exact same thing. The point is, being a tool specifically for or most focused on the lateral movement attacks, there is no log or any trace of this activity anywhere. And this is actually one of the difficult things to do. You can simply do something like this as well. So let's say we do not want this Kerberos golden activity alert to be seen. You can simply try this. So of course, you need not have access to the console all the time. I'm using these IDs so that it's quick to demonstrate. So if we look for this particular activity, if you run it like this, you can get, sorry, if we run it like this, we can get a list of all the activities, and it's in a chronological order, so you can see the latest activity here. But in case you would like to go after a specific activity or a specific alert, let's see it, go to edit, and in place of doing anything else, we can simply, here is a property called is visible. We can simply set it to false. Save it, and if we go to the console now, it's not visible. And once again, there is no trace, no logs of anyone doing this activity. So that is gone. And you cannot retrieve it from the console right now. What someone needs to do is to go back here, look for the activities, and set its visibility to back to true. Now there are so many other things you can do. For example, what I was trying to do and couldn't complete, because it does not need any authentication, we can simply leave a reverse port forwarding proxy if we have access of port forwarding on this box, so that this is forwarded to one of our boxes somewhere, and we can interact with the MongoDB from a remote session or remotely. Then you can, of course, inject your own profiles. Need to just have a look at a couple of unique things, which takes time to build, so I cannot demonstrate that. So we have seen, I think, this and this as well. So What is the defense against the evasions which we have seen? Of course, the well-known Active Directory mitigations like limiting your domain admin's logins or architectural changes proposed here can be used to avoid the attacks, not specifically ATA evasions. How you can defend your ATA installation is think over it if you would like to make it part of your domain or not. If it is part of the domain, please keep in mind that it would be easier to attack not only to find it out, but also to attack it. For example, ATA, in some installations, there are specific groups called ATA administrators, ATA users. Microsoft suggests these to be just role-based groups, that is ATA administrators are, let's say, the local administrators. But in some installations, I have seen actual groups like ATA administrators, ATA users. So that means the normal group enumeration can also give away the location or that there is an ATA deployment. So not making it part of a domain could be a good decision as far as at least security of the deployment itself is concerned. Hopefully password for backend DB would be installed. Of course, you can, let's say, if you have administrative access, you can just exfiltrate the whole database, but that at least includes or puts some cost on an attacker. Not having any password just makes it very easier for any attacker to tamper with the alerts. And of course, some way of logs when if someone is tampering into the database or tampering with the activities in the database, some logs or additional alerts possibly, if not alerts because it's in the same database, at least some logs into the Windows event log, right? So that should also help. Now, there are some limitations of ATA. If you go to this documentation, there are only certain protocols which ATA detects. Reads and detects alerts from them. There are attacks like, let's say, constrained delegation attacks, or there was a very popular attack a couple of months back where you abused the membership of DNS admins group. These are not detected by ATA. Why? Because ATA needs a normal traffic and an anomaly to detect those things. If it does not know what an anomaly is, if it lacks, let's say, signature of an attack, it cannot detect it. Yeah, and that's the thing I was talking about. Let's say constrained delegation or DNS admins attack. Now, other than bypass, there are some avoidance techniques as well. Tickets like Silver Attack or Kerberos, which either need no communication with the domain controller or need minimum communication with the domain controller, are also not detected. Of course, if you are not talking to the DC, ATA cannot read the traffic, and there would be no detection. Now, how, as a red teamer, how can I avoid ATA forever? So for that, try not to escalate to domain admin privileges, just so that you can brag about it in your report. We escalated to domain admins, and it was possible for us to access all the boxes. I mean, who doesn't like to write that in the report? But avoid that if you can. If your goal is to go for a specific box or any specific piece of information, which should be actually, then just do not go after the domain admin as the very first thing. Also, ATA allows you to create honey tokens. That is, you create let's say a rogue domain admin and specify that here in the ATA configuration. Okay. Here in the honey token accounts, you specify the SID of that account, and as soon as that particular account is used, even for normal thing, or even if just someone uses its ticket, there would be an alert here. So avoid unnecessarily going after DA. Before going for the lowest hanging fruit, which all of us have been taught, just think for a moment, is it really the lowest hanging fruit, or is it a honey token, which you can, of course, enumerate from, for example, let's say looking at the last logon time of a user and similar attributes. Uh, Yep, that's about the evasion part. Just stay focused on the goal of your assessment. Do not unnecessarily do try to do cool things like golden ticket or skeleton key if not required. I mean, who would need a golden ticket in a red team assessment of 1 month? I don't think anyone would. Uh, and if you're using it, be ready for detections. Now, limitations of the research, of course, all the bypasses or things which we have seen there in the bypasses, we focused only on the anomaly-based detections, so no behavior-based detections. While interacting with the ATA team, they for many times they told me the same thing, that, for example, even if you can bypass overpass the hash detection, if you access a new resource using that, or behavior-based detection will catch you. I mean, could be. I've never tried that. In my labs, I have never seen a single behavior-based alert from now. The AT installation has been running for past 11 months. So could be true in real-world environments, but not in my lab at least. For attacking ATA deployment, we need local admin privileges. That's what we assume. That's a requirement. I mean, that's a limitation, basically. We assume that we have that. So we can say that, to conclude with, is we can, of course, bypass ATA, as we saw here, but it still provides, not specific to ATA, and some of the bypasses which we saw here are not very specific to ATA. Many Active Directory detection tools look for the exact same thing. Of course, I cannot name them right now, but look for the exact same thing. If you use attacks carefully like this, you may bypass many of them. And modification of attack methodologies and the work culture of red teams may go a long way, just to see how cool it is to mention skeleton key, golden ticket, or other headline attacks in your report. Just avoid that. I mean, that's fantastic if we can avoid that. Not only saves us time, but detection as well. That should be it from me. If there are any questions, I would be glad to take them.